Sun, like all stars, is a giant incandescent ball of gas. Its surface is not solid, it's gaseous. The gases are mainly hydrogen and helium. Violent internal chemical reactions keep the surface gases constantly churning and erupting. When compared to other stars, it's an ordinary star of medium size. Nevertheless, its size is gigantic. Its diameter of 860,000 miles is over 100 times larger than that of the Earth. Its mass is over 3,000 times greater than Earth's. Surface gravity is 28 times greater than that on Earth, and its age, like Earth's, is 4.6 billion years. The Sun spews gases deep into outer space. This type of curved eruption, which explodes far out into space, is called a prominence. Its arcing form is shaped by powerful magnetic field lines, and its light is from charged particles trapped inside. The prominences flow along the field lines of local magnetic disturbances. They originate and terminate at the local magnetic poles. And periodically, many such magnetic disturbances rage across the Sun's surface. The forces are so powerful that prominences can be catapulted as far into space as would reach from our Earth to our Moon. Sometimes, after just a few hours, the gases fall back into the Sun when the magnetic field suddenly collapses. Other times, the prominences may float in space for weeks. Of all solar eruptions, flares are the shortest, lasting only minutes, and the most violent, created by nuclear fusion explosions equal to millions of hydrogen bombs. So violent that, like earthquakes, pressure waves race across the surface of the entire Sun within a few hours. Superheated columns of gas from the interior constantly bubble up into the exterior layer of gas, the photosphere. There, it cools off and sinks back below the surface the way boiling water does. Although each of the rapidly rising and falling columns of gas measure about 780 miles across, scientists call them granules because they look like granules in boiling water. Sunspots are giant surface eruptions of gas triggered by magnetic disturbances. Many are much larger than Earth. Their centers photograph darker because they're cooler than their surroundings. The Sun is not an especially hot star. The temperature of the photosphere, the surface gas, is about 5,500 degrees centigrade. But gases spewing up from the interior are much hotter. Prominences are 20,000 degrees and flares 100,000 degrees centigrade. For unknown reasons, the corona, gases ejected the farthest out, reach a temperature of 1,000,000 degrees centigrade. But the highest temperatures can be found in the Sun's interior. Its core is about 15 million degrees centigrade. At that temperature, hydrogen nuclei are traveling so fast that when they collide, they fuse together, forming new and larger nuclei, those of helium. This continuous process of thermonuclear fusion liberates enormous energy, which radiates out to the Sun's exterior and then far beyond, traversing our entire solar system at light speed in 5 hours before heading out into the wider universe.